unlocking the mysteries of uranium, from discovery to global impact. Uranium is a word that sparks a lot of curiosity and sometimes even fear. We often hear about it in connection with nuclear energy, atomic bombs, and even science fiction stories about radiation. But what exactly is uranium? To understand it, we need to take a closer look at what this element is, how it was discovered, and why it plays such a major role in both energy production and human history. Uranium is a naturally occurring chemical element, identified on the periodic table with the symbol U and an atomic number of 92. That means each atom of uranium has 92 protons in its nucleus, which makes it one of the heaviest naturally occurring elements on Earth. In fact, if you were to pick up a chunk of pure uranium metal, you'd find it surprisingly dense, about 19 times heavier than the same volume of water. That sheer density is one of the reasons uranium has so much potential as an energy source. Let's explore right here on History of Simple Things. The history of uranium's discovery is quite fascinating. It was first identified in 1789 by a German chemist named Martin Heinrich Klaproth, who was analyzing a mineral known as pitchblende, now called uraninite. Klaproth named the new element after the planet Uranus, which itself had only been discovered a few years earlier. However, it wasn't until much later that scientists began to understand the full significance of uranium. For most of the 19th century, uranium was used mainly for making colorful glass and ceramics, because compounds of uranium can produce a distinct yellow-green fluorescence. People had no idea of its radioactive nature at the time. That changed in 1896, when French physicist Henri Becquerel discovered that uranium salts emitted invisible rays that could fog photographic plates. This accidental finding opened the door to the study of radioactivity, later developed further by Marie and Pierre Curie. So uranium's story is deeply tied to the history of modern physics. From a chemical standpoint, uranium is a silvery gray metal, but what makes it so special is its nuclear properties. Uranium atoms are unstable, and they can undergo radioactive decay. There are several isotopes of uranium, but the two most important are uranium-238 and uranium-235. Isotopes are atoms of the same element that have the same number of protons, but different numbers of neutrons. Uranium-238 makes up about 99.3% of natural uranium, while uranium-235 makes up only about 0.7%. This small fraction of U-235 is what makes uranium so valuable for nuclear energy, because it is fissile. That means U-235 can split apart when struck by a neutron, releasing enormous amounts of energy in the process. This phenomenon, called nuclear fission, is the basis of both nuclear reactors and nuclear weapons. The energy released by splitting just one atom of uranium is tiny on its own, but when you multiply that by trillions of atoms undergoing fission, the power becomes staggering. A small pellet of uranium fuel, about the size of a fingertip, can produce as much energy as burning a ton of coal. That's why uranium is such a crucial element in today's energy landscape. In nuclear power plants, uranium fuel rods are carefully arranged inside reactors. When the atoms split, they generate heat, which is then used to produce steam, driving turbines that generate electricity. This allows countries to produce vast amounts of electricity without burning fossil fuels, which makes uranium an important player in the fight against climate change. However, this energy source is not without controversy, because it produces radioactive waste that must be carefully managed for thousands of years. Beyond peaceful uses, uranium has a darker chapter in its history. During the 1940s, as part of the Manhattan Project, scientists discovered how to harness uranium's fission properties to create atomic bombs. The bomb dropped on Hiroshima in 1945, known as Little Boy, was fueled by highly enriched uranium. Enrichment refers to the process of increasing the proportion of U-235 in uranium, making it more suitable for weapons or reactor fuel. This discovery forever changed global politics and warfare, as uranium became not just an element, but a symbol of destructive power. Since then, uranium has been at the center of debates about nuclear proliferation, energy security, and international peace. Mining and obtaining uranium is another important part of its story. Uranium is found in various minerals in the Earth's crust, and significant deposits exist in countries like Canada, Australia, Kazakhstan, and Namibia. Extracting uranium involves mining the ore, then processing it into a concentrated powder known as yellow cake. From there, it can be converted into uranium dioxide for reactor fuel or further enriched if needed. The mining process itself raises environmental concerns, such as contamination of water and exposure to radiation for workers. So it's a field that requires careful safety measures. Despite these challenges, uranium continues to be mined because of its irreplaceable role in nuclear technology. Health and safety are always big topics when discussing uranium. On its own, natural uranium is only weakly radioactive, and it poses more of a chemical hazard than a radiological one. Handling small amounts of it doesn't immediately cause harm, but inhaling uranium dust or being exposed to high levels of radiation from uranium decay products can be dangerous. That's why strict safety protocols are enforced in the nuclear industry. Another important fact is that depleted uranium, which is uranium left over after enrichment, has been used in military applications, such as armor-piercing ammunition, due to its extreme density. This has sparked debates about the health consequences of using depleted uranium in warfare. Uranium is more than just an element on the periodic table. It's a symbol of human progress and human caution, a metal that has fueled both our brightest hopes and our darkest fears. As humanity continues to search for sustainable energy solutions, uranium will remain at the center of the conversation, an element that challenges us to balance innovation with responsibility. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.